Alright, welcome back, guys. This will be part 2 of the lesson 2.7. In part 1, we discuss the notations and definition of some of the marginal functions that we study in this class, and these notation will come up over and over again. And we went over one example, how we apply the concept derivative, which is through marginal functions, and being able to find the or approximate the exact cost of producing certain item, and that was in the previous video. In this video, we're going to do an example from the same lesson, and we are going to excuse me, we're going to look at marginal average cost function, and we're still gonna use the exact cost formula to estimate certain item is produced, how much of the certain items is being produced. But in this example, we're going to look at the average cost function. Okay, so we're given the total cost function, which is 90,000 plus 300x, is the total cost of manufactured X auto body frames. In part A, we also find the average cost per unit if 100 frames are being produced. Okay, so part A, we want to find average cost per frame or per unit if 100 frames are being produced. Okay, so that's what we have to find. So to find the average cost per frame, we will need to find the total cost of producing 100 frames first. So that is just 90,000 plus 300 times 100. And that will give us, let's see, 90,000 plus 300 times 100. So that will give us the total cost of 120,000 of producing 100 frames. So if we divide that by how many frames produced, and then that is essentially the average cost, okay, per unit. So if we take that total, divide by 100 frames, that will give us $120 per frame on average if 100 frames are being produced. Okay. All right. So part B, we want to find the marginal cost, the marginal average cost at production level 100. Okay. So now part B is asking us, what will be the average cost is increase or decreasing at this current level of production? So marginal average cost at 100 frames being produced. That is C bar of 100. Okay. Well, C bar, we have to find the C bar function first, is C of x over x. So that's 90,000 plus 300 x over x. So that will be just, so C bar of x is going to be 90,000 over x plus 300x over x, so the x cancels. So that's just going to be 90,000 over x plus 300. So that's our average cost function. So to find C prime of 100, C bar prime 100, we have to take the derivative of the average cost function. Okay. So what you want to do is you want to rewrite this as 9. I'm going to go ahead and rewrite this first. So 90,000. Okay, so I'm going to go ahead and bring the x first. Bring the x up. So 90,000. X to negative 1 plus 300. And then we're going to find the derivative of this, which is dx of that. So now C bar prime of x is going to be, this is going to be 0. Okay, so using the power rule, we get 90,000. Okay, 90,000. And then x minus 1 minus 1. So we're looking at 90,000 over x squared, which is the marginal average cost. Okay, So now we want to find the marginal average cost at the current production level of 100 frames being produced. So C bar prime of 100 is minus 90,000 over 100 squared. Okay, so let's go ahead and do that. 90,000 divided by 10,000. Okay, so it's going to be minus $9. Okay. So to quickly just to interpret this answer here, this answer means the average cost per frame or per unit is decreasing at a rate of $9 per frame when 100 frames are produced. Okay, which makes sense, right? So the more units are being produced, as far as bulk item goes, the average cost per item will decrease over time, because if you produce a mass number of items at once, you are the fixed cost and the variable cost will be cheaper. Suppose you have a machine that can produce up to 500 items, and you use a machine to produce 3 items, so you have to hire the guy to use machine, and then the cost of operating machine as well. But imagine if you increase the production, so the fixed cost and variable cost will stay low or actually decrease over time. So in a sense, the average cost per item in this case is decreased. That's why we have a negative, because as more items being produced, the cost per item will decrease over time. So that's the interpretation of that value. So part C is asking us to use part A and B to estimate the average cost per frame if 101 frames are produced. So how do we do this here? So if the average cost of producing 100 frames is $120 per frame, and is decreased. Let me just circle this here, and it's decreasing. So this is the average cost producing 100 frame. The average cost per frame is $120 when 100 frames are produced, and it is estimated that at that level is decreasing by $9 per additional frame. So per additional frame, okay, when 100 frames are produced. So part C, okay, so the average cost when 101 frames produced. So we said when 101 frames are produced, okay, we take C bar of 100, okay, and we're gonna subtract that or add that to in this case is C prime here. All right, C bar prime of 100, okay, and this will give us the estimation of the average cost of producing 101. Okay, all right. So this formula here come from the exact cost formula. Exact cost formula. And that is C prime of X is estimated by can be estimated the exact cost, which is Cx plus 1 minus C of X right there. Or if we apply that to average cost function, we have the same result, similar result, right? So this is using the derivative to estimate the exact cost of producing on average an X plus 1 item. So if we want to figure out, what is the average cost for producing 101, we just add that over there, and that's what we have here. Okay, so now that estimation is going to be $120 plus negative $9. So we're looking at 111. Okay, so this here is saying that this is saying that the estimate average cost per frame if 101 frames are being produced, which makes sense, right? So if you increase your production from 100 frame to 101, you expect on average cost per frame will be decreasing or be cheaper, and that is by $9 cheaper. Okay, all right.